Okay, in part 2 of section 2.1, we're going to look at some new notation for functions and then evaluate functions. So in the past, you have worked with many equations and that are solved for y, that model behavior in the world. Most all equations we work with are solved for y. Here are two very commonly used, line and a parabola. And today we are just going to extend this notation of y, and we're going to rewrite it in function notation, and we're going to replace every y with f of x. This is just a symbol, f parentheses and an x. It doesn't mean to multiply. It just helps us to be able to identify problems when we have it in this notation. I'll show you an example in just a minute. But this right here is replacing the y, so it's the dependent variable. And it's read f of x, or f at x, and it's just a symbol, and it denotes, when you look at this f of x, the independent variable is inside the parentheses, which is x. That's your independent variable, and of course f of x itself is the dependent variable. So like if we were talking about area formula of a circle, instead of writing y equals, whatever, square ax squared, power squared, we can write it, we could choose a for area, and r could be your independent variable. So a of r equals pi times r squared. This is function notation. The independent variable is r, and the dependent is a of r. Or you could just write it a. These two are equivalent, but the first one identifies the independent variable, and the second one just has the dependent variable a. Now we can be given a formula. Let's say f of x is given to be x squared minus 3x plus 4. Now if I want to find, let's say, the value of y, or f of x, when x is 1, I can now just say find f of 1. So f of 1 means I would substitute the x becomes a 1, and I just plug a 1 in like we've always used to doing. Evaluate that. So f of 1 equals 2. F of 1 equals 2 can be written as an ordered pair, where the x is 1 and the answer y is 2. We could be asked, if we're given the same function up here, to find f of negative x. To find f of negative x, we replace every x with the new given negative x. And remember, when you square a negative, it becomes positive, so this will become positive x squared, and these two negatives multiply, end up being positive plus 4. We might be asked to find negative of f of x. This means like a negative 1 multiplied by the whole function. We're not replacing a negative 1 in place of x. We're multiplying negative 1 by the function if we're asked to find negative f of x, which would become minus 1x squared plus 3x minus 4. Each of these would just change sign. And then we could be asked to find f of anything, really. Let's say we're asked to find f of x plus h. This is a very commonly used input. X plus h is the input, so I would plug it in place of each x. And work that out. I have to write x plus h down twice to multiply all that out. I have to distribute this negative 3 by both numbers inside or in the parentheses. So my final answer would be x squared plus xh plus xh. So I have 2xh plus h squared minus 3x minus 3h plus 4. That is f of x plus h. Now, somewhere in this lesson, you will be asked to evaluate the difference quotient, which is a basic concept in calculus that many of you will be taking after this one or after you take trig, and then you go into calculus 1. The difference quotient is a formula which is find slope of a secant line. All you really have to know is how to use it in this particular course. So if you were asked to find the difference quotient given, or for this function up here, we'll use the same one, you have to find f of x plus h, plug it in here, then subtract from that the given function and divide everything by h. Well, now for this particular problem, we've already found f of x plus h. You have to put the x plus h into this function, which we did, and we got a while ago, x squared plus 2xh plus h squared minus 3x minus 3h plus 4. So then I have both of my pieces that I need. F of x plus h goes here, and it replaces it, and I will subtract from that f of x. So I would have x squared plus 2xh plus h squared minus 3x minus 3h plus 4. That's f of x plus h right there. And I got a minus from it, f of x. Well, f of x is given, so to subtract it, I will change all the signs of each piece in it. Then I will divide all of that by h. Now, a lot of this stuff should cancel out. I add x squared and minus x squared, minus 3x and plus 3x, and plus 4 and minus 4 adds to 0, so I have left 2xh plus h squared minus 3h divided by h. Now, always when you do that step, every term that's left should have at least an h in it, or some power of h in it. So if I divide each of these three terms on top by h, I get 2x plus h minus 3. And that would be the final answer. This is like the most difficult problem in the section when you're asked to find the difference quotient and you're given a particular function. But your first step is to plug x plus h into that given function to find f of x plus h. And then you're just going to subtract these two, divide everything by h. And we'll work one more of these at the end, but right now we're also going to look at operations of functions, which is just no more than adding, subtracting, multiplying, dividing two or more functions. The notation looks a little bit different, but the actual math is the same as it has been in the past. So, we'll just try a few. Let's say we have f of x given to be x plus 1, and let's say g of x is 4x. If I wanted to evaluate the sum, or f plus g of x, all I have to do is I add the f of x plus g of x. So f of x is x plus 1, I put it here, plus g of x is 4x, so my answer is just 5x plus 1. The notation might look a little new, but the math is the same. So if I wanted to divide these two, I could ask for f divided by g of x. Remember, this x is just showing you the independent variable that we're using. So this just means f of x divided by g of x, which would be x plus 1 divided by 4x. Do not cross these x's out, because this is a binomial, two terms on top. They're both divided by 4x. You can't just cross the x's out. This is the final answer, this whole thing. You might be asked to multiply f times g of x, which just means f of x times g of x. 4x times x is 4x squared plus 4x times 1. You could be asked to evaluate one of these at a number, like f of 2 plus g of negative 1. Well, f of 2 is my input, so I would put 2 in for x, and add to that g of negative 1, where negative 1 goes in place of my x in that function, and I get 3 minus 4 for a final answer of negative 1. So operations of functions is no different than just math we've always done. It's just indicated a little bit different manner. Let's do one more, a little bit harder, that has some fractions in it. Let's say f of x is the formula is 1 divided by x, and g of x is x divided by 2. And let's say we're asked first to add these. I need an LCD, which is 2x. So I times this first one by 2 over 2, and the second fraction by x over x. So they both have 2x on the bottom. And I get 2 plus x squared divided by 2x. Maybe we were asked to divide these. F divided by g of x. The f of x goes on top, so I have 1 divided by x divided by x over 2. Remember, when you divide in fractions, you invert and multiply the denominators. That becomes 1 over x times 2 divided by x, or 2 divided by x squared, etc. We're going to work one more difference quotient problem, and then we'll leave it to you to go and work in my math lab for this section. Let's say we were given these two functions. We'll do linear this time. F of x equals 5, or this function, 5x minus 3. And I'm asked to evaluate the difference quotient for this particular function. And remember, I will give you this formula that finds the slope of a line between 2 points. It's a basic formula of calculus. And really, all you have to do when you're asked to find this is just you got to find f of x plus h. So I'll plug x plus h into the function in place of x to get 5x plus 5h minus 3. And once I get that, I'm going to subtract from it f of x. So I will have f of x plus h written down first. And I'm going to subtract f of x, which means I will change both signs if I want to omit one step, and divide all that by h after it's reduced. This cancels to 0, this adds to 0, and I have left a term that has an h in it, which I will divisible by h, and the final answer is 5. So in this part 2, we looked at function notation, how to find the difference quotient, how to evaluate a function at different inputs, and operations of functions. You should now be ready to work the homework in 2.1.